All right, we want to choose a sample size. So notice my margin of error is my z star times the square root of pq over n, p hat, q hat really, okay? We haven't done our study yet. So I don't know what p hat is because I haven't taken my sample. I don't know what n is yet. I don't know how many successes there are. I don't know rho, otherwise I wouldn't be creating this in the first place. What do we use for p hat? We use something called p star, okay? Oftentimes there will have been a pilot study that is similar to your study, and you can use that p hat from your pilot study to get a decent sample size. Or you can use 0.5, which would make this 0.5. 1 minus 0.5 would be another 0.5. It maximizes this standard error. You can't get any bigger than 0.5 times 0.5. So that way you're guaranteed to get something less than whatever m you get. Because if you use 0.5 and you estimate an n to be 72, well, when these become 0.3 and 0.7, your margin with that sample size of 72 is guaranteed to be less than it was with 0.5 and 0.5. Okay? So let's give it a shot. So a company received complaints about its customer service. So they're going to hire a consultant to carry out a customer survey. Before they contact the consultant, they want to know how big of a sample size will they need to pay for. And so the president of this company wants to be within 3% of rho at the 95% confidence level. What sample size should she choose? So we want to look at this right here. We need our z star times p star, 1 minus p star, over n to be less than m. Well, if it's 95%, we know that the z star is 1.96, and since we don't know any p hats, we're going to use 0.5 and 0.5, okay? If you start solving this, first thing you want to do is isolate the square root. So we divide by 1 point, or I guess you can square root the 0.5 times 0.5, but you want to isolate and divide, basically multiply by square root of n, divide by 0.03, okay? And then you would get n, square root of n is greater than or equal to 32.67, and you get n of 1067.11. So it's literally solving for this n, which is kind of messy because it's in a denominator in a square root. You could divide by 1.96, square both sides, take a reciprocal, do whatever you need to do. You know that n is not going to be negative, so you don't need to worry about multiplying or dividing by any negatives that would cause you to flip this. But what do we get to conclude? Okay, you want to round this up now and say, choose a sample size of 1068 to guarantee a margin of error of less than 3% at the 95% confidence level. This, by the way, is why a lot of your sample sizes for national polls ends up being right at 1,000, because then they're plus or minus 3% is the margin of error. Okay? So anyhow, have a wonderful day, and we'll see you soon.